So we've got pattern blocks, these are just matchsticks. And then we've got these new funky tools, which are called GeoStix. You've got a set on your table. What I would like you to do is, before you touch them, I would like you to close your eyes and picture a triangle in your head. So close your eyes and picture a triangle. Does your triangle have 3 equal sides? Does it have 3 corners? Now, using as minimum sticks as possible, so minimum of 3 sticks, can you please make your triangle? I stole this one from Matt Sexton. So if you could hold up your triangles. And again, this is what I would do with students. So have a looking at the different triangles that are around the room. You can explicitly teach them that, you know, we've got ones that have got all the same side, but we've also got triangles that are different sizes as well and different sides. And for the upper years, you could talk about the actual terminology for these triangles, but for the junior school, it's a really good opportunity to teach them that not all triangles are, can I pinch that one from you? Look like that, okay? And if it looks like that, it's not upside down. If it's flipped over, it's not a triangle that's back to front. It's a triangle no matter how it looks. But this is a triangle as well. So it's a good way to show non-typical shapes. What I'll get you to do now is I would like you to close your eyes again, and I would like you to, in your mind, draw a hexagon. Does it have 6 sides? Are they all the same size? Are there 6 corners? And then open your eyes and make your hexagon using 6 sticks. Abacus sell them, Officeworks actually sells them, but slightly different. They have bigger packages with curves and stuff in them, so it's pretty cool. But Abacus, I don't know if MTA do. You might like to check with MTA while they're here. So I pinched this lesson idea off Matt Sexton, who's the new leader of the MTLC Centre from ACU. And the biggest learning I took away from him is to maybe try and stop calling these 2D shapes and start calling them figures instead. And then 3D objects are our solids. So solids and figures are good words to take away for here. But what I really like about this one particular lesson is we've got our typical hexagon that a lot of you did make. So got Ryan, can you hold yours up? And can you hold your one up? And can you hold your one up? And this one. We've also got non-prototypical hexagons as well. And it is so important for us to be exposing kids to this, that our hexagons don't always have to look like this. As long as there's 6 sides and 6 corners going on, that's also a hexagon. So just at the back of my classroom now, I've just got a poster of I did this particular lesson with my preps and ones earlier in the year, and they're all the different hexagons that they came up with. And then we talked about quadrilaterals as well, and triangles.
Because these are flexible, you could say, does the area change when you manipulate
Yes,
the shape?
yeah. Yeah, so what a perfect opportunity now to then extend this to the grade 5, 6s. Okay. All right. Then you could get them to then make it. Okay. Also, this particular manipulative comes with little projectors, so you can be talking about the different angles within as well. It's really important that our maths displays, when we're doing 2D shape displays, that they're not just typical prototypical shapes. And I always talk about the word diamond. It is a rhombus. It is not a diamond. If that's on your displays, please remove it or change it. And I always say to my kids in Prep 1 that they're going to write a letter to Play School to tell them to rename the window, because diamonds come from the ground. Okay. And I also do talk to them about the actual shape of a diamond. If you were to draw it, would be a 3D solid or a solid, and it looks a little bit more like a pentagon with 5 sides anyway. And I'll finish on just sharing this one. This is just these are geo shapes, which I don't think I brought them out for you today. I was going to get them out for you to play with, but I did not do that. So these are old school. These have been around forever. These can also be purchased from MTA as well, or Abacus. And these are brilliant for teaching nets, and I mean, these are just your squares, but you can get them in different shapes as well. So really good one to teach solids as well. But I really like the use of these because they're flexible and the kids could make them differently. I do know that the GeoStix also at Officeworks, they do have a 3D element to them as well.
Marissa, what is that down the bottom? Are they just toothpicks with, no?
Yeah. Yeah, they're just matchsticks that they've just used blue tack.
Yeah, okay.
Yeah. So that was a grade 5 class. We were talking about non-typical 3D solids. And where might we see a shape like that? So we then related it to authenticity, and we might see that might be a bench seat in the city somewhere, or a table. Yeah, paddock, especially around here. So this is just a really nice lesson to talk about your nets. How many different ways can we make a cubed net? This is a lovely Maths 300 lesson. We weren't sure. We got to 10 and then we weren't sure if there were 11. We did have an 11th, and then they convinced me that the 11th wasn't working because it was the same as one of the others. So they're the same if you can turn them, and they end up looking the same when you turn them. But if you can flip them, or rotate them, they are different.